Today we're looking at ticket number 12414 and it's a PS4 Slim that doesn't output to a TV. I've already done a bit of investigating with this one and it's not the usual HDMI port swap. We seem to have bigger issues at hand. Just move the fume extractor out of the way. I'll talk you through my logic, what I've ascertained so far, and we'll go from there. So let's go over to the scope. To start with, I'll show you inside the HDMI port itself, and as you can see, it looks to be A-OK. No bent pins, nothing like that. I was originally worried about here on the back of the port. The solder looks a little bit messed up. However, believe it or not, the port is definitely factory, so I don't understand how that's happened on the back. The customer took this apart to give it a clean, and one thing I am concerned about is we've got incorrect screws put in here, and also an incorrect screw that's gone here. So I'm hoping that that's not causing the issue. Might be lucky, and it does look like ground, but as you can see, there are a lot of wires on the board. First things first, the fuse. I'm just checking and making sure that we have continuity, which we do. Like I said, these things have been tested already. If we turn the board back over, you might see a little bit of solder on this pin, which was me. And the reason being is because I was measuring all of these pins in diode mode to ensure that I had an accurate reading for all of the data lines and power. They all seem to be fine, except for this one, which actually comes back as ground. Now, before I looked at any pinouts or anything like that, I followed the trace, which goes all the way down over into the HDMI encoder IC. And to be specific, I think it's 8 in from the left up here. This actually reads 0. And I was thinking to myself, what are the chances that's actually meant to be ground? Quite slim. Then I took a donor board. I have 2 of them on my desk in front of me, and I can confirm that I believe that is meant to be ground. And instead of just going ahead and replacing the HDMI IC, which ultimately would be the quicker way of doing things, I wanted to cement my workings out before I did that. I then again went back to basics and I have measured continuity on the filters to ensure that we don't have any crosses or anything and that they just go straight through, which they do. Now there was one little concern, and that's this diode here. When I read the diode in diode mode, I get a reading this way, the red probe is on the bottom, I get a reading this way of 2.4 voltage drop. If I switch the probes around, I get a reading of 0.7. Now I thought personally that when you're measuring a diode specifically, you're only meant to get a reading one way, not two. And that logic does apply to other diodes that I've measured on the board. So again, this is on the back of the board, and if I measure here, I get 0.7 drop. If I switch the probes around, I get nothing, I get open line. And the same on this one, 0.7, other way around, nothing. And just to triply confirm, I'll do it here as well. On this one, nothing. Switch the probes around, 0.6. And why not just do this one? Nothing this way, something this way. So again, I went to donor boards and I checked that specific diode that I was getting a reading on both ways. Lo and behold, I get a reading on both ways on both of the donor boards that I have as well. So now I'm a little bit confused. I went back to the board for further investigation. And again, this is on the back where you have the fuse. And I was just probing around in continuity mode to check for any shorts first of all. And then I was checking this little transistor here. Now with the meter in diode mode, I get 0.6 here, I get 0.2 here, and I get ground here. On these top two, on the left one, I get 0.4. Here, however, I get nothing. I get open line. And I was looking at the trace and I was like, there should be something here, right? Ultimately, if I flip this exact location over, it goes to around this area of the board on the other side, which is just east, I guess, depending on how you're looking at it. But if we're looking at the chip that way, east is this way. Now, I'm going to yeet this board out of the way and I'm just going to grab a donor board. This is the exact same model, same component, just about here. And if I measure here, I get 0.6 voltage drop. Whereas on the board that I'm currently working on, I get 0. For the sake of it, I'm going to grab another donor because I didn't just want to write that off. So here's another donor board and I measure it just here, 0.6. I'm going to take off this component. It could also be that this cap is faulty. Wait for it to cool down. That's factory flux. Apply a tiny bit of flux to the area and just re-tin these using leaded solder and a soldering iron. There we go. Try and keep hold of our little replacement IC. There we go. Watch it flow into place. Push down to secure. There we go. Quickly just go over the legs. Make sure they have a solid connection. There we go. Now this might not work, but thought it'd be a good little test to start with at least. Give it all a nice little clean. Lots of flux. Bring in the isopropyl. Okay, now let's measure and see if we get the same reading, because if we do, my guess is it is probably going to be the IC on the other side. So I've got the meter in diode mode again. Red probe is going on ground. And what reading do we get here? Aha, we get 0.6. Okay, so maybe it was that actual transistor. Yeah, 0.6 here as well. And here, 0.3, 0.2, and 0.5. Measure in resistance mode from here to here. What do we get? 16K, which is perfect. And between here and here, we get 4.7K. Wicked. Other than that and the diode that I was just talking about, I don't see anything else wrong with this. So I'm going to semi-put it back together and see if it works. And I'm really hoping that it does, because it will be a cool fix. I've just been to test, and amazingly, it didn't work. I still have the reading of 0.6 in the top right, so I don't know whether this would have just had to be changed anyway. I don't know. But now my attention is with the HDMI retimer IC. So we'll take this off the board and replace it. Failing that, we'll go for the port. But again, I've tested every single pin on the port and it looks fine, but looks can be deceiving. Sometimes these chips can be a pain to get off the board, especially if you don't have big enough tweezers, but I'm hoping mine are going to be okay. We're about to find out. Don't need to replace the solder on these, just put a tiny bit of flux. Let's grab our other one. There we go. That looks about right. It should flow into place. If not, we can definitely give it a helping hand. Whoa, whoa, whoa. Relax, relax. So we're definitely going to have to give it a helping hand. You need to chill out. Oh my gosh. Alright, looks like I'm going to have to give it a little nudge downwards, just to make sure it doesn't fly about. And then hopefully come in with the reflow. Okay, so that should be on there. Lift up the tweezers. There we go. See it pop into place? Nice. And we make sure we go all the way around the chip, to make sure that solder connects with the IC. Come off of it. And now I'm going to give it a final push down in a second. There we go. And we'll push down. And take the heat off. Okay, should be good to go. Double check our work. But first off, a clean. And now check and make sure that they're all lined up and connected. Yep, seem fine that side. Maybe there's one there that doesn't have enough solder. Maybe I should go around the corners. Yeah, I'm going to go around the IC. And just make sure that they are all connected, because that one doesn't look like it's got enough solder on the bottom either. In case you can't see the one that I'm talking about, it's just here. So I'll just go around the IC. So flux. Just like that. Soldering iron with a bit of leaded. Okay, again a nice clean. Get rid of all this flux. I will like to add as well, the first thing I done was tested the hard drive. It was more so blinking on the screen, just saying that it couldn't find the HDMI. That error came up every 5 seconds or so. Let's check the IC now. Good. Good that side. Mainly we're looking for no bridges as well. That's fine. And our final side here Could do with a little bit more solder. There's solder on those pads, but I think maybe this side could do a little bit more. We'll go over that. A little bit of flux. Solder on the very tip of my iron. Just run it past. Check this side now. There we go. Don't have any bridges, and they all look connected. Let me give this one a test now. Now, you probably can't see. I'm going to zoom you in as best as I can. Let's have a look. There we go. Okay. Let's not zoom in on me right now. But if I show you that, you can see that we have an image. So replacing the retimer worked. I don't know if replacing that transistor on the back aided towards the fix, but I wasn't getting a read in there before. And then when I switched the component, I was. I hope you enjoyed the video. Thank you very much for watching, and I will see you in the next one. Peace.